Okay, so a sketch of our vectors. Well, I haven't labeled everything, but it's clear that these are the points, 2 points. These are the 2 R vectors, and these are the 2 force vectors. Okay, since these are the triangle we get here and the triangle we get here, the 2 triangles are similar, then just by straight geometry, without having to write out all the expressions, we can conclude that these distances are identical, so these forces will have identical magnitudes. And of course, they're in the same direction, and by geometry, we then, simple geometry, we see that this force makes the same angle with the x-axis that this one does, but in opposite directions, right? Okay? So that, among other things, the x components of these forces will be equal and opposite, and the y components will be equal. So when we add these 2 forces, we're going to get only a y component. See how big that y component is? We do a parallelogram. And here is our force vector. This chalk seems to have a mind of its own. So I apologize, but we see that there's a force vector, right? And of course, by the geometry of this rhombus, we can, and by the symmetry we have down here, we see that we have to have symmetry along the y-axis. And you want to really think about that. Symmetries are extraordinarily important in engineering and physics, okay? So think as much as possible in terms of symmetry. Okay.